very often, when something became almost desperate and something new happened. And this is what happened is that Alex Miller and George Bednoes published this paper saying the possible high TC superconductivity in barium-lead copper oxide system. And they mentioned the TC can go up to 30 degrees Kelvin. At that time, as I mentioned, the record was 23.2. So because of this paper, both later on, in this 1986, 88, they received the Nobel Prize, okay, the two persons. Their results was presented here. How much time do I still have? Huh? 20-something minutes. Okay, thank you. Now you can see this, their result, their data were published in a German journal, it's shown here. And basically just resistivity measurements. And in order to show, at the time, they did not have the magnetometer to determine whether Meissner effect is there or not. But they used that indirect method just by changing the measuring current, as you can see here. And when they're changing the measuring current, the transition temperature shifted down. And then that decided that it is a superconducting phenomenon. Because of this curve and so on, they got the Nobel Prize, okay? So the paper was initially greeted with skepticism by most, except a few groups. Few groups, including the Tokyo group, because the Tokyo, Tanaka has a student working in their group, so therefore it must be true. So they believe it. And the other was Houston. Our group has been working on the oxide for a while, but we missed this cupric oxide. So therefore, when we saw this, we said something must be there. And then Beijing group and IBM group also, because IBM and Zurich lab, they are too closely related. So these are the group. So the Houston group and the Tokyo groups confirmed these results and announced that in 1986 MIS4 meeting, that was December 4th, 1986. That was very exciting. And the Tokyo group further identified that 25 degrees Kelvin superconducting phase was so-called 214 phase. Don't worry about it. We'll call it 214 phase. And this was very good to determine that. But it also occurs because when people realized the phase, and everyone jumped in the 214 phase. But we took a different approach. Instead of looking at 214, we decided to look for new high TC phenomena. And that's how we got to the YBCO thing, situation. So as I just briefly show it to you, during that period of time, we look at the material by applying pressure, and we found the transition temperature went up to 40 K. It shows a very large pressure effect, higher than many other materials. And then the second thing is we continue to raise it to 52.5. But then later on, when we tried to realize during the meeting, the MIS meeting, Tanaka, Kitazawa, Tanaka's associate, told me the superconducting phase was 214. So I decided to get the paper from Huntsville, Army Arsenal's library, and following that, and purify the material to 214 phase. The interesting thing is this: once we purified it, and this high temperature signal disappeared. So we decided the high TC is not due to the 214 phase, but other things. And this was a blessing for us. So then, actually, in November 1986, we already saw a diamagnetic effect up to 70 degrees Kelvin in the lanthanum barium copper oxide phase, here. So there was no doubt in our mind that superconductivity at higher temperature must be possible. At that time, I made two major decisions. The first, I invited M.K. Wu, my former student, to join the search. In fact, I remember I told him, if we work together, we can beat the world. He still remember that statement I made. And then, indeed, we were very successful later on working together, and then focus on the real high TC instead of the 214 phase. These are the two important things. So then, at that time, it's near the end of the year, when I went home, and my wife told me you should do something useful. So that's close to Christmas time. So he asked me to write a greeting card to my colleague, Ching Wu Chu, who was at North Carolina, Chapel Hill, as a professor, asked me to tell him the following. Basically, I said, just got the highest TC of 40.2 Kelvin, and next week, very likely 50K, and now I'm full of confidence of 77K, because at that time, that was the holy grail for this field, try to get to 77. But at that time, I really told him that situation. I'll tell you why I was so bold at the time. At the same time, I also dropped Alice Miller and George Badnott a note telling them, I tell them that we reproduced their results and it is superconducting. At the time, they were very depressed. When the paper came out, people did not pay any attention. They thought this was not true, you know. So when we sent this to him, they were very happy. So Alex Miller immediately called me and thanked me. I said, we should thank him. But then this thing, apparently, Badnott kept this note. 10 years later, he sent this to me, you know, as a souvenir, 10th anniversary for YBCO. So then, really the exciting things was at the beginning, even at the end of beginning of 1987, we already saw superconductivity all the way up to 90 degrees, as you can see here, you know, December. But unfortunately, the thing is not stable. But for us, we were certain that superconductivity above 77 degrees Kelvin must be possible. So then later on, M.K. Wu, his group, and our group, we produced pure sample with yttrium replacement in the material, and we saw the resistivity measurement and also the susceptibility measurement here. So there was no doubt superconductivity happens in this material above 77 degree Kelvin. So we sent it to PRL and published in PRL, and then they came out, the paper finally came out on March 2nd paper. March 2nd, that day was an exciting time. In fact, many people thought that day was a super day of physics, because not just high temperature superconductivity, but also supernova was observed at that time. And then for those people in Texas, we were talking about building a superconducting super collider. So everything was super, you know. So that's called super day of physics. As you know, SSC finally was canceled and was not realized. I still think if it were built, I think right now the physics center would not be in Europe, but rather in the United States. You know. So after that discovery, we immediately looked into the compound. We said, okay, why yttrium so important in this material? So we decided to determine the role of yttrium in the compound. It turns out we realized this rare earth elements in the compound basically just serve the purpose of building up the structure, you know, building up the structure. And the electrons were decoupled from the rare earth elements. As a result, we immediately discovered a whole bunch of a series of compounds, as indicated here. I still remember when this was discovered, I was lecturing at Harvard at that time, right before the ATS meeting. And then I actually, in the presentation, I put point by point in my transparency. And then after that lecture, I immediately flew back to Houston and wrote up this paper and sent it to PRL for publication. So that was the exciting time. So later on, we studied this material. Basically, you can see this layer cupric material can be decomposed in two groups. One group is